Okay.
I can see it.
Yes. Yes, I can see it.
Okay, the idea that time is concordant to our perception and our frame of reference, of temporal reference, yet different to another person's frame of reference, dependent on motion, as Einstein outlined in his work of special and general relativity, is essentially stating that we are conscious according to the parameters of space-time, and how that flows dependent on what our reference of relative motion is. It's almost like saying that your consciousness, how you perceive, is directly wired to the workings of a clock. That's what Descartes presented in his initial Cartesian coordinate system, especially in line with his format of logic, and it's what Einstein ran with his theory of special and general relativity. Yet the question that we're all facing with relativity, is there a scientific mathematical link between frames of time as a relativity of time in space? Surely, in not considering how each frame of temporal reference can be linked mathematically, and think of consciousness as these temporal reference frames of reference, then all the facets of physical reality and time as equations of time will logically not even match up to our own way of being conscious. To the point of most basically gravity and electromagnetism. So this lecture and associated paper, which the paper I've published is on my webpage, and it's a transcript for anyone who wants to just get a rewind of what I'm saying here. It's all transcripted onto a paper. What's happening here? I'll present firstly the historical notions we have of time in science as applied to scientific congress, and then discuss those problems that have been presented to us in using that axiom of time. Most importantly, that not knitting together those temporal notions of those different frames of reference traveling at different speeds, it presents us with the mathematics of space and mass and energy that are never knitted together as a mathematical equation in time. Only though in using Einstein's equation of E equals mc squared and the idea of gravity as the curvature of space. So a new axiom for time is presented as a basic mathematical algorithm that through the development of the papers demonstrates its ability to knit together most of what we know of physical scientific data, including Einstein's well-known equation. The quest of this lecture and associated paper is to demonstrate that it is possible to marry up electromagnetism with gravity using a common mathematical function for time, universal in space, as temporal relativity, despite it offering a new set of equations for known physical data. Then I won't present the proof. The proof I've got for the work, the actual experimental data, is online. It's in paper 7. But I'll just run through it briefly when I get to that. So the structure of the lecture here, I'll go through perhaps intensively the historical perspective, the thought experiment, and the new algorithm for the time, and then I'll just skim through the paper summaries very, very quickly, and then conclude with defending the golden ratio and go into some conclusions. So just as an introduction, we can't introduce the subject of time and relativity if we don't really understand what Einstein was talking about when he was talking about time as being how a clock tells the time, and how he related that directly with one's perception. For instance, if it can be stated as a thought experiment, that to be conscious of or as a theory of everything, it would require, if you're conscious of everything, it would require a stable consciousness through the entire spectrum of time and space one is examining, then it would be true to say that any variation in time through that spectrum would represent a variation of consciousness, and thus understanding of that system being examined, if indeed the assumption that Einstein presented of consciousness being tagged to time, to the perception of a clock, is upheld. The problem, though, with the reality in constant motion of varying speeds presents us with the case of different accounts of time, and thus consciousness, and thus awareness of the system being measured. How indeed, therefore, can we arrive at a theory of everything when there is a vast spectrum of time variation in play owing to the nature of bodies in motion and the effect of time there, as specified in Einstein's special and general relativity? The argument of this lecture is that using special and general relativity isn't sufficient to reach a theory of everything, in that it will never join the two basic forces, electromagnetism and gravity, because one key variable is fixed as the speed of light, and the other key variable, mass and gravity, is fluid as per gravity, changing the nature of the relative motion and thus speed between mass, and thus also time in the process. And thus it presents as an impossible equation to consciously reach in the context of aiming to examine that system accurately. So what this lecture proposes is a standard for time, for each reference of time, a common algorithm, regardless of the relative motion of the objects, as that way the idea of time can be scaled for each reference of motion of a body in reality, and by such a mechanism, using that mechanism, make it possible to arrive at an equation that should link electromagnetism and gravity. One key assumption in this lecture that will be carried is the notion that consciousness is concordant to the awareness of the passage of time, which I mentioned previously, that the conscious experience is determined by the flow of time, as Einstein presented with his example of someone traveling at near light speed, namely that time would slow down, yet the occupant of the craft would be none the wiser. The problem with relativity using simple linear time is that on the one hand, perception appears to be the standard, and on the other, it negates the idea of a universal reference of stable consciousness, and thus a theory of everything owing to the different rates of motions of objects. And so what use is that, using that process? A universal reference of stable consciousness is like the idea of holding the understanding of reality as an understandable entity, as a feature of being conscious. The question is, how do we get to that scientifically? How do we construct that algorithm for time for each reference of a body in motion? The first thing we need to consider is how and why we arrived at the idea of relativity and time's role there in the first place. So now we move to the how did we arrive at the idea of time and consciousness? I'm thinking it began with Descartes. The point being made here is that it's the question I'm asking is, how does science theory evolve? And I ask myself, am I allowed to present a model for time beyond the entropic arrow? Is that allowed? The point being made here is that, excuse me, I think it's okay to present new ideas for anything in physics. Yet something as profound as time needs explicit focus, and anyone needs to go to great lengths to respect that process historically. Let me explain that. For instance, modern science is not merely an examination of reality, it is a test of scientific paradigms. Most notably, prior to Einstein, was the achievement of the Cartesian coordinate system as presented by René Descartes as a three-dimensional space and associated one-dimensional use of time. The Cartesian coordinate system and one-dimensional time is still used in the frame of reference of special and general relativity. In fact, it was the Cartesian coordinate system that gave genesis to the idea of relativity, as per tagging the Cartesian coordinate system to consciousness, which Descartes achieved through his work in presenting not just the coordinate system, yet a model of logic and thought. What this new theory for time proposes is a paradigm shift to a new understanding of time, as the current paradigm for time, as explained, doesn't seem to be as useful as it should be in finding a theory of everything, of linking electromagnetism and gravity. Now, in respect and honor of physics and how processes like these can take shape, these new proposals, for instance, in 1962, Thomas Kuhn, in his book The Structure of Scientific Revolutions, argued that the process of observation and evaluation takes place within a paradigm, a logically consistent portrait of the world consistent with observations made from its framing. He argued that a paradigm also encompasses the set of questions and practices that define a scientific discipline. He characterized normal science as the process of observation and puzzle solving, which takes place within a paradigm. Whereas revolutionary science occurs when one paradigm overtakes another in a paradigm shift. So according to Kuhn, a paradigm shift occurs when a significant number of observational anomalies arise in the old paradigm and a new paradigm makes sense of them, which is precisely what is being suggested in this presentation with the new proposal for time, namely resolving the disparity between the different references of bodies in motion at different rates of speed and thus resolving their time dilation variations and thus perceptive frames of reference. So according to Kuhn, the proposal here for this upgrade to time isn't breaking any strict rules. Fundamentally, though, the concept employed here is in using time as a process that transcends the convention of mathematics. Time being defined as more fundamental than mathematics, as though it's a set relationship of its own kind, as an entity more fundamental than mathematics, which can therefore employ mathematics a certain way, as a certain relationship of functions, as a certain equation from which other equations can arise. And the case in point here are all the key equations of physics as per outlined in the papers that I've published. The point here is that a fundamental logic is being accepted not just as consciousness would operate, yet how it is pinned to time, as Descartes and Einstein suggested. The issue here is, how does that concept of time allow our consciousness to reach a theory of all space and time as opposed to an impossible equation presented by the impossible to calculate options of special and general relativity? The answer is find a common algorithm for all references of time and then apply it to space, and thus one's perception of it. And so how did I derive the new algorithm for time? And what is that new algorithm? To answer that question, I have to do what Einstein did. It's a thought experiment. It's along his line of thinking. The aim here is to explain a general platform, an understandable platform entire of all of space and time as something we can use our conscious experience to examine and test and confirm time after time in an absolute sense through that matrix of thought, that tautology. Ultimately, therefore, we are essentially proposing a type of universal model of consciousness, or more precisely, logic. René Descartes knew it was imperative to present a basic model of logic with his coordinate-space system. And as such, we have tagged the conscious reference with that coordinate system through the centuries. Excuse me. Let's do a thought experiment, though, on the notion of Einstein's relativity and how our consciousness could cope with extreme, if not absolute, considerations of time and space. For instance, for a person on a craft traveling at close to speed of light, the issue is there a noticeable change in the perceptive reference of time for that person? The assumption is no. The question is important because it suggests that space-time and the operation of time is fixed to human perception. That is the assumption of Einstein, as was the proposition of René Descartes, without being so clearly stated at the time. Let us, though, take the hypothetical craft to light speed. as though time no longer passes. To go at light speed infers the craft will ultimately move forward to the point as though time does not pass. So for it to get up to light speed, and paradoxically at that speed, time is not passing. To go, it would almost be as though it's standing still if time isn't passing. But to go faster than that is to travel even more absurdly back in time, in theory. And as a conscious experience, the only thing that we can relate with in regard to traveling back in time is a memory. And which essentially contradicts everything we know of the physical process of time and space, because as we know through the arrow of time and entropy, it's contradictory. But if we're tagging our consciousness with time and we can have a memory, it almost presupposes that traveling back in time is possible. So let us suggest, though, that to do that safely is to create a type of theoretical magical doorway in space, just hypothetically speaking. The mechanism being light traveling in space without space overcoming that light in some regard, in that magical doorway. In some regard, owing to our ability of memory, it is as though human consciousness is already linked into a process that is already traveling super light speed the system over for us to have our memory ability, and thus could imply that given our ingredient in reality, that reality operates on a standard of already being at light speed and beyond, which this is part of the thought experiment I'm presenting. How can everything be already traveling at light speed and beyond as our conscious ability of existing in a now event with the ability of memory suggests? What I'm basically saying here, if Einstein tagged human perception to the clock, the idea of time, and we're looking at something that is going superluminal, super light speed, and that's going back in time, and we have a thing called memory. I'm just diving into all these little things, all these little assumptions that we haven't addressed. As physics knows, it's difficult to imagine, let alone theorize, namely reality functioning at a level of light speed or even beyond light speed. So perhaps the answer can be found not by trying to answer that puzzle of tagging our consciousness with time so directly and so profanely, but what if the answer can be found in a function, a potential function itself of time that's creating this riddle of consciousness that we seem to relate consciousness with time with? The question is, what function of time? What are those variables? So this is the struggle, that leap into the theoretical unknown. As presented here, there are two features to our consciousness that we know absolutely, namely that firstly, we are conscious in a now event, a time now event, and this is standard. So let's call this, I call it Tn for time now, and give this a standard value of 1 arbitrarily as a flow of time from past to the future. The second feature of our consciousness we know absolutely is our ability of memory. Let us call this TB as time before. The value of time before is the issue we seek to resolve from that thought experiment, as technically it implies super light speed if we are to compare consciousness with time, and time is related to space. Yet fundamentally, it can be said that TB would exist in comparison to Tn as a negative value, as it is going against the flow of time as we perceive it as Tn. Our quest now is to tag these two basic characters of our conscious ability with time together in a manner that makes fundamental sense. And this is the part that those words then lead to the algorithm, the new algorithm for time. It's I've tried to present it as simply as possible, but here it goes. In mathematics, an equation is a statement that asserts the equality of two expressions. To present an absolute equation for time requires a type of equality to be established between two expressions of time. What can we say about time that has two expressions using both 1 as Tn and Tb as an expression of equality? We traditionally have related time before to time after along a basic linear mathematical construct as Tb to Tn to Ta. But as is becoming clear, it might not be as simple as that. So let's break it down further. For instance, we know that placing Tb next to Tn requires a negative sign for Tb, given Tb would be a backward negative step compared to in reference to Tn. So the fundamental property A would represent equation 1 minus Tb plus 1 equals fundamental property A. We don't know what to marry that up with yet, but we can just say it's fundamental property A. Yet, if time is a singularity, we can present the case that Tn can also be per negative Tb. If time exists primarily in Tn, we can say that Tb is per, it's a function of Tn as another equation for the flow of time, as technically Tb would already be contained within the Tn construct, as it would have already happened. So this is equation 2, fundamental property B, 1 over minus Tb. The question now is regarding their relationship, fundamental property A and fundamental property B. If these two features represent fundamental process to time, and time itself is a singularity, then fundamental property A must equate to fundamental property B. So then we come to the equation, minus Tb plus 1 equals 1 over minus Tb. Essentially, we are taking two proposed properties of the mathematical relationship between Tb and Tn and equating them together as the algorithm for time. So in just those three fundamental steps, that's the algorithm for time. Minus Tb plus 1 equals 1 over minus Tb. From equation 3, we arrive at the following equation, equations 4 and 5. Tb squared minus Tb equals 1, Tb plus 1 equals Tb squared. Equation 5, though, is interesting. Tb plus 1 equals Tb squared. As essentially it suggests that if we consider an arrow of time equation that is absolute and we add the past as a positive value, as it would be in considering an arrow of time equation to Tn as past plus present, only logically we would arrive at the future, which is the fourth clear step here. Let us call this Ta. So Tb plus 1 equals Ta, where Tb squared equals Ta. So we're taking the concept of time, which as a process here would transcend the standard convention of mathematics, of set relationships, the thing that Wittgenstein was doing. And we're suggesting that the concept of time is defined as being more fundamental than mathematics, is a set relationship of its own kind, and as an entity would be more fundamental than mathematics, and thus can employ mathematics a certain way, as a certain relationship of values, as a certain equation. This theme runs throughout the papers that demonstrate the worth of this algorithm and the use of the algorithm for time as it must. Such is how this new axiom for time is being introduced, not derived from mathematics, yet from the nature of time itself and how that relates with our perception, and then applying mathematics to that fundamental basis, applying all the exotic algorithms on top of this fundamental basis. So the question now is that I was faced was, is this the common reference universal time algorithm that we need to link all observable data of reality? Is this the equation? The only way to know is to apply this time algorithm to 3D space. as though building a theoretical model of reality from this new axiom for time. Thus, as a proposal, it is a conjecture which needs to be demonstrated correct with the operation of time in space and all that associated data to find completeness for this new mathematical tautology, logic for time. And this is what I've done in papers 1 to 7. I take this algorithm for time and then I apply it to three-dimensional space. And knitting that algorithm together in three-dimensional space, it derives all these equations. It derives all the equations. It derives the equations of electromagnetism, of gravity, the fine structure constant, the Rydberg constant. It's quite interesting how this evolves when it is applied to space. If I can summarize the 7 papers very briefly and their respective achievements, if that's okay. I highlighted in paper 2 how space, in being a property of TA, time after, would represent the combination of both values of the golden mean equation, geometrically singularities at right angles, giving the result of 3. So the fundamental step that I made in applying time to space was in using space on TA and then using the 2 results of the golden ratio equation, which is TB plus 1 equals TA, or TB plus 1 equals TB squared. It generates theta and minus 1 over theta. If both of those values are squared as TA, as TB, as though they were TB, each of those variables were TB, and then put to TA as a square value, and then put at right angles to one another, the hypotenuse there, the skew there is the value of 3, which is the value of 3 is 3 times Tn, 3 times 1. So for me at the time, I just thought this on a fundamental level, on the fundamental level I'm referring to, it just makes sense to apply it to the idea of the 3 arrows of space through which time can operate. And I reached that at paper 2. I explained that at paper 2. And from paper 2 evolved.
Excuse me, can I ask a question about paper 1?
Yes.
Okay, you are starting from mathematics from the Fibonacci series and deriving the Rydberg constant. The
Yes.
Rydberg constant has dimensions. It's a dimensional constant. The
Yes.
Fibonacci series does not. It is
Yes.
not possible to derive a dimensioned quantity from a mathematical construct. At some
Yes.
point, a scale has to get in there,
Yep.
and therefore, just a priori, it looks as if your derivation in paper 1 is impossible.
Yeah. Yeah. This is what I'm saying. It was as though with each paper, I never had the complete explanation. It was like a piece of a jigsaw. Yet I saw the merit in the time algorithm nonetheless. So I knew that I could get a certain picture view of the Rydberg equation and algorithm, and then I knew exactly what I had to do. I'm exactly in agreement with you, and that's why I had to do paper 2, because it doesn't exist. So ideally, I want to write a complete paper with all the papers together and put it in the right numerical order. But at the time, the style of my writing, the style of putting all this together, it was like putting a jigsaw puzzle together. I had to make these leaps of faith. And then, paradoxically, the last paper I wrote, paper 8, it's better to read that as paper 0, because it explains Descartes, it explains Einstein, it explains how consciousness is tagged to time. But at the time, I was using I it's something I haven't revealed in the papers, but I was using a three-dimensional complex number mathematical grid. And the complex numbers sort of came out in paper one, and then I had to get rid of the idea of the complex numbers because I showed that paper to a mathematician years ago, and the algorithm was over 200 pages long, and he said you're going to kill someone's brain if you show them that. So I had to I had to really condense it down, but I didn't know how to do it. And back then, I didn't have the golden ratio algorithm. I didn't see. To me, the golden ratio algorithm was something that hippies would talk about before they travel off to the stars. But when I finally really put my hands in the dirt, it really became apparent that the algorithm does work better than what I had previously, the complex number algorithm. But I agree entirely with you that I made a leap of faith there. It was a big one, which the first thing I had to do after making that leap of faith was then say, okay, where are the three dimensions? Where are they? So that's the first thing I did in paper two. And thank you for pointing that out, because that's it's a bit of a theme that's running through all my papers. You get to paper two and you say, but you haven't said this, and you get to paper three and you say, but you haven't said this, and then you get to paper 5 or 6, and then you think, well, okay, now you have to prove it. Now you have to demonstrate that gravity does emerge from electrodynamics in a lab. So I had to go through all those different steps to demonstrate that. And I won't talk about all the papers. Well, I'll see what I can do. A simple summary is, in paper one, I developed the initial algorithm for time. I addressed the issue of tagging time to 3D space, which isn't completely true. I tried to address the issue of tagging time to 3D space. And I demonstrated that the golden ratio fit in well with the Rydberg constant. It seemed to be a perfect match, but I still had to then get to paper two to I couldn't develop a wave function without developing the 3D grid. But at the time, it was very difficult to actually know what I had to do next. So I thought if I developed the 3D grid, then time on that 3D grid would be apparent as a type of wave function. So that was paper two. Then paper three, I tried as best I could to present the idea of consciousness. I didn't want to lose the idea of consciousness because I knew it was important to paper 8, which I hadn't even written, which was the explanation of the Einstein paradox of light traveling faster, our memory, and all that thing. I didn't even have any of that when I was doing these papers. I only had that in the last few months. But at the time, I addressed the idea of the emergence of consciousness from chaos to see if the Fibonacci sequence featured in any of those chaos equations. Then I went to paper 4.
Could I ask
Yep.
another question here? It's been fairly thoroughly established in the last century in analyses of mind versus brain, of the way mind emerges out of brain, that consciousness is not fundamental. It's entirely a function of brain activity. It has an entirely material origin.
Absolutely. Yeah.
Yeah. So you can't have an emergence of consciousness from chaos when chaos is presumably a very fundamental phenomena. You'd have to discuss the emergence of neural activity or of simple biological clocks in the first instance. And by bringing in the word consciousness, you add a great deal of ambiguity, a question which has been discussed enormously for the last 2,500 years, which isn't really necessary to an examination of fundamental physical properties. And I think you may be giving yourself way too much to cut off in one attack.
Yeah, it was the title of the paper was a tongue-in-cheek thing from Greek mythology. Their belief back then was that consciousness emerged from chaos. And so if I could demonstrate that the golden ratio algorithm was intrinsic to the chaotic equation, the equation of chaos, and when I use chaos, it doesn't seem to be chaos to me. There seems to be order there. And if I've got the golden ratio algorithm there, I'm basically saying that consciousness, as you rightly say, it isn't embedded in chaos. It does emerge, through however many layers of development of that Fibonacci sequence. It does emerge as consciousness, which is why I presented those pictures earlier on of the flowers with the Fibonacci sequence, or the spiral patterns. They're all the pattern of the Fibonacci sequence as growth patterns in time. But my point here in this paper was to suggest that if I could link the Fibonacci code into the idea of chaos, and we already know that the basis is that the Fibonacci code is associated to consciousness, I was just merely saying chaos would come first. I didn't say chaos emerges from consciousness. I said consciousness emerged from chaos. I think that was the only point I was trying to make. Otherwise, I would get into, I think, a lot more trouble if I said chaos emerged from consciousness, I think.
May I ask a question?
Yeah.
So if I'm understanding you right, you said chaos does come first, but the Fibonacci sequence sort of irons it out, and out of that comes consciousness?
It's tough because I think the word chaos, and I don't know why they used the word chaos when they used it in terms of the chaos equation, the Brownian motion, and all that sort of thing. I think there's actually, if I've proven that there's a Fibonacci sequence order to it, and this is exactly why I titled the paper this way, because I knew it was going to get questions. I thought it's an old subject. Everyone likes talking about the idea of, what if consciousness did emerge from chaos? And it's just an impossible thing to understand in a laboratory. I mean, how do you create true sentience? Is it possible to do that in a lab? Can we create life? And with the implication of my statement in saying that consciousness can emerge from chaos, it sort of throws everything out the window with the baby. But that's not what I'm saying. I'm sort of giving hope I'm sort of capturing a bad title and putting a lot of good in there to say that there's still more to come. And I think with paper 8, actually my next paper that I'm working on, which should be ready in a month, it takes the whole, it addresses paper 3, and it says that the golden ratio time algorithm fits perfectly with a model of consciousness. So in other words, I finally linked through all these series of papers the idea of the Fibonacci sequence with consciousness itself. And I present 3 classical models of consciousness in the last 20th century of 3 of the greatest philosophers who presented their models. They basically didn't realize it at the time, but there is an embedded golden ratio code that fits with the time code as a model of consciousness. Subject, object, the whole thing, being, superego, ego. So I'm sort of saying that consciousness, it's always there. Like you could say, if there's a Fibonacci sequence in a rock, is a rock conscious? I don't think the rock has the ability of consciousness, but it exists in the context of consciousness. The context of either a greater consciousness or in relative position to something that is conscious, more conscious than it, because it
In order for it to exist, it has to be in a thought somewhere.
Well, yeah, it has to be a type of free choice. Yeah.
If you'll excuse me, that sounds like a really silly statement. Thinking that to discuss a rock, you have to discuss some kind of universal consciousness. Can't the rock just be a rock? Does it have to be a pet rock?
No, I'm not. I'm not saying the rock is conscious at all. I completely agree with you. That's not what I'm saying at all. I'm saying that certain things have certain higher qualities than other certain things. And consciousness itself, and this is, and I knew I was going to get torn apart on this subject, which is why I have to do the last paper on science, consciousness, and time, which is, I think, going to be the title for it. And I explain exactly what makes consciousness consciousness. And it's very difficult for me to explain that now without actually having that material floating around. And it wouldn't be right for me to talk about it completely without actually having it obviously published first, because there's some really groundbreaking ideas in that paper that I'm putting together that have, even as a past medical student and who studied psychiatry, done psychology, it's it's very interesting. It's very, very interesting that of how a time algorithm can represent consciousness in a layered format, and what that program is. Part of the theme of all the writing that I've done was, part of the algorithm of time is that it seeks to trace a perfect circle. It's as though it's an algorithm that seeks that sort of perfection. And in paper, I think it was the Relativity of Time, paper 6, I think I explained consciousness as not the forward motion of time, but the reverse of time. The consciousness is fundamentally a process of reflection. And when we try to look ahead, that's when we look into the darkness. That's when we get into trouble and form all these sort of strange ideologies and whatnot. But consciousness, I'm saying, like a rock is conscious forward, but that's not consciousness. A glass bottle is part of the normal arrow of time, but that's not consciousness. What I'm going to present is that consciousness represents the opposite. And I've got that algorithm, I think, in paper
So consciousness is always sort of looking back.
yes.
Okay. And you're postulating that perhaps space, time, thought, or consciousness aren't the separate things they appear to be?
Well, they're linked, but on the one hand, it's like subject and object. I mean, you're looking at the objective reality of one direction of time that's not consciousness, but you're the subject that is conscious in the opposite direction of time. And that was why the initial puzzle, the thought puzzle I presented, was that why are we more predominantly conscious with our memory? And like I've noticed, I've worked with people who have Alzheimer's and whatnot, and primarily Alzheimer's is losing your memory. As you lose your memory, you lose your ability to function consciously. It's part of that process. Our memory, our exercise of remembering things, looking into the past. It's embedded in what we are as a sentient being, primarily more than someone just staring into the distance hoping to do something. It's our memory that really sort of makes us who we are. That's not necessarily my personal belief, but that's what it seems the logic of this Fibonacci sequence is saying. So I'm compelled to give it a chance and to find out why it's telling me this, why I have to write this down, and is it real? Is it true? And I think, sharing it with people, it tells me that there is something there. There is something there. But to answer the question on whether a rock is conscious, no, that's part of the normal sort of process of time. I don't really want to talk about it too much, but the last paper will demonstrate that consciousness is a a cascade effect into the past. It's like a Fibonacci sequence going into the past. That's consciousness. But to do that, to create life that way, well, that's another story. You can create things in normal standard time, but to create something that has memory patterns, and this will come out in paper 8, you need a vast source of stored memory with all these different commands and options that then that computer has to go into, that has it pre-programmed in the past into it, that it can look into and then act as though it is a sentient being. I mean, it is possible to create sentient beings, that process, but to say that a computer today is a sentient being is like saying it's just not that evolved yet. It's, give it maybe 2,000 or 3,000 years, yeah, sure, but right now, no. But the whole process is having that memory. Memory is essential to sentience, as normal consciousness would be. And that's why in the thought puzzle I presented, I said, you know, let's go to light speed. No, hang on, let's go super light speed. And now let's talk about consciousness. I hope that.
Then if given enough memories, data, then
Yep.
a computer will find that it has an easier time to becoming consciousness than not.
Well, to making decisions, yeah. Well,
Okay.
well, technically, you're looking at a computer program that has data inside of it that is either going to more efficiently look after itself, and to more efficiently look after itself, it has to know where it's getting its electricity from. It has to know where it's getting its cleaning from, its maintenance from. So when you're talking about sentience as something that's been programmed with its environment in mind to look after itself, you're still looking at something that is performing to a certain task to become more circumspect in its environment. And that is one of the fundamental equations of the Fibonacci sequence, to ultimately resolve the difference between the real value of pi and the value of pi that it constantly calculates on a quantum level. And the real value of pi, the only way it can do that is if it goes completely off the charts, like completely circumspect around itself and gathers itself with all these other different sort of wave function, quantum wave functions to resolve the problem of finding a perfect circle.
Well, even with all that, will it ever be self-aware?
Well, that's the question. Well, I'd say that, yeah, well, that's the big question, isn't it? I mean,
That's
how
what
do you,
sparks it to life. What brings that spark into
well, yeah,
reality?
like, is an insect just a program, a program of nature? Is it self-aware? And are humans the only ones that self-aware? There are people who believe that humans are the only ones who are self-aware. That dogs aren't really self-aware. They don't have that sort of self-recognition, or cats. Some people, I'm not saying it's me, but I'm saying there would be a point in the spectrum about evolution from a grain of sand to where we are now, where our self-awareness became where we had enough memory in our data, we had enough association with our environment to actually recognize that we are self-aware. And part of me doesn't want to talk about that in the next paper, but part of me does. Part of me thinks that I'm just going to end up in a lot of mess for saying something that people might confuse with my own belief, other than what it. I want to present something that actually scripts as logically as possible from what the algorithm is suggesting. I don't want to go anywhere else other than that. So, yeah, I'm trying to stay on the rails as much as possible with what the theory is suggesting. But the fundamental feature is that consciousness primarily is something that echoes into the past. That's,
I understand. I think just the other day I asked the question: is a spider aware of God? You know, and
yeah.
which I don't know if we could ever know that, but that means that if it isn't, that means that all these insects around here are just little robots, biological robots, but just robots.
Yeah. Yeah. It's I think there are ways to. It's a tough question. It's a tough question. I mean, you could almost argue that if humans are self-aware and we eat spiders and we eat fish and we eat cows, then they develop by some sort of strange association in the greater sphere a certain sense of self-awareness. I don't know. I don't know how that works, but we eat chemicals, we eat minerals, so that the logic doesn't apply. It's important for me to stick to what is being suggested by the theory and not deviating from that. So I have to yeah. Um,
How
and
big is your algorithm, if you don't mind me asking?
how
Your
how long is it?
Fibonacci. Well, how big is it? Yeah, how long is it?
How long is the algorithm? You saw it. It's only 2 or 3 pages.
Okay.
That's the algorithm. Yeah,
Okay.
yeah. Um, but what the true algorithm is the geometry that's required to have it have the wave function of that algorithm when applied to three-dimensional space satisfy the value of pi. And the only way it can achieve the value of pi is if it does all these really, really different and vast things that, as it seems, present with all these different facets of how it can achieve that. One of those is the fine structure constant of the atom. One of them is Avogadro's number. One of them is the the equation of gravity. The other one is the equation of electromagnetism. So it does all these things. But when I thought, you know, should it do these things? Should something like that time algorithm actually do this? Or is it up to something else to just say, no, this just fits in the Goldilocks zone of how the Big Bang happened? Um, and so it had to, in the theory, the hardest bit was explaining the cosmic microwave background radiation, the field of view of the stars, what that represents, what the redshift effect is, what we actually see, or is it a distortion of light that's traveling to us from um, a more close region of space? Um, it's in the theory. I think the key thing I said that the theory is just a proposal. It's not something that should be taken as gospel, but it's a set of ideas that coincidentally come up with all these accurate equations. So it was my task just to, look after that orphan, that orphan theory, because technically, um, it I still have to be a physicist. I still have to honor and recognize all the data, all the data that we have, and not deviate from the data. The moment I use data that is incorrect is the moment the whole thing falls apart, and I would not do that. So I depend on data that represents, the DNA of all the standard physics equations that we have. I cannot deviate from that. And that sort of keeps me on track. If I find that the theory is going somewhere that conflicts with data, I just drop it. I think that's not going to work. And I think that's how I sort of developed all the writing.
Excuse me, speaking of data, um, I, I'm finding this presentation, quite frankly, a little bit vague. Like that time as energy has also dimensional problems because time and energy have inverse dimensions. Um, but speaking of data, do you make any specific observational predictions which are different from what we know, which are unexpected? That was in the How to Think About Weird Things book that I talked about yesterday. One of the key tests of whether something qualifies as useful science. And that, for instance, Einstein in special general relativity made very specific predictions about the perihelion of a progression of Mercury, the slowing down of time in high orbit or at high speeds, excuse me, the speeding up of time at high orbits and the slowing down at high speeds, and so forth, numerical things which have been tested and are at the foundation of like the GPS systems we use to drive around. Do you make any specific numerical predictions in your theory?
Well, that paper 7 is the paper that tries to outline an experiment that says that an EM field of destructive interference, when applied to its two opposing coils, will result in a type of gravity field effect. And I reached that through the theory. I didn't think that why don't I just throw in there? It's what the theory was suggesting based on all the modeling. So I put the experiment together. I used the microwave magnetron, and I got the right wavelength, and I put it in the right diameter tube. And sure enough, I got a result. It wasn't a result that I expected. I thought I'd just get a slight movement, but this thing, it was held down by a spring, and I wanted to fly across the room. And modern science can't predict that sort of thing. And I published that paper, and I published the video. It's on the website. And reading that paper makes me think, well, that's something science can't prove. That's new data. But I don't disagree with any of the results that Einstein proposed with his theory, because technically everything that Einstein proposed using the arrow of time, it's absolutely correct. It's absolutely correct. I just make it more, I change the way the theory is explained in terms of spatial transformations and time dilations. I changed that description by using the phi quantum wave function. So as I said at the very, very beginning of the lecture, I don't change the data, I just change the way the data relates to other data. And I use that with the new wave function. But I don't disagree with what Einstein predicted, because the theory here actually predicts the same things that Einstein predicted.
So you were saying that you actually have a result which is not predicted by standard theories of electromagnetism and shows an induced gravitational effect of some kind in a specific experimental arrangement. Is that a correct restatement?
As I would like to confirm it, because it only worked. I did hundreds of tests, and with that type of configuration, that and the tests began after paper 1, 2, or 3. The recent tests, there are only 2 tests. Well, actually 3 tests, and every time that the test was performed, because of the amount of force that resulted, it just tore everything apart. And it's just expensive. Like it's ideal to have these tests done, at least, to have at least 50 tests done. I would be happy with the result.
Well,
But my reason, yeah,
was not about the result of the test, but
yeah.
whether the abstract experimental setup predicted something unexpected. I didn't ask how the test came out. My question is your approach testable? Is it sufficiently specific that it can give us some observational numbers which will be different from our standard approaches?
Yes, well, that's what paper 7 is. It answers that question entirely. It presents the hypothesis, and it goes through the numbers with that hypothesis and what to expect, and through what time dilation to expect that gravitational result. Because the problem with the result is there's a type of time compression the theory says there's a type of time compression, so it happens very, very quickly. It's not one of those slow things. And
then
I
if somebody ran that experiment and showed that there was no effect to an appropriate degree of experimental certainty, you would concede that your approach is an error.
Yeah, well, I would test it myself and make sure that I had explained the paper correctly enough. I would make sure that I did everything.
What I'm trying to get at is, are you prepared to say, if this result is not seen, then I am wrong? Are you prepared to say that?
I would say that I never said in the paper that this is absolutely proof of the theory. I said this requires more investigation. This requires more study.
You see, you're backing away from a requirement of science.
No. I'm being honest. I'm being absolutely
I
honest with
understand
what I
you're being
wrote in the
honest,
paper.
but for your approach to be taken seriously, you have to be willing to say, if we don't see this, I'm wrong. That's a requirement of science. It's a requirement of Einstein. He predicted, for instance, the bending of light around a star, the very celebrated result. It's a requirement of the predictions of, say, the Casimir effect and so forth. You say, I stand by my analysis. I project it to this case, and if we don't see what I said we should see, then I am wrong. Are you
I would say I was wrong with the way the experiment was conducted. I wouldn't say I was wrong with the theory.
Then you see, that's a critical divide here. You can put any, as Feynman said once, you can put any weird hypothesis out there, but you have to be prepared to say, if we don't see it, I'm wrong.
Well, despite all the equations that have been derived, despite the idea of consciousness, and despite the idea that with what will be released in paper 8, would I say that the thing is, I did all these experiments, and I put patents in for the last 5 years, and I was wrong with a lot of those patents that I put in, and I admitted it. I walked away from that, but every time I walked away from those patents because I had the wrong design, I thought, where the hell am I wrong? What have I done wrong here? And then I was scratching my head thinking, I've used the wrong diameter tube, or I've used the wrong diameter wind, and I make all these silly errors but I wouldn't say the theory is wrong. I would say my ability to be a NASA engineer at the Jet Propulsion Lab is waning. I wouldn't say the theory is wrong.
That's my problem with the paper you're putting forward here. I have a delightful book called Einstein's Mistakes, about 25 errors that he made in his career. We all make mistakes, that's fine. But at some point you have to say, I've gone over the analysis, I've double checked it, I've cross checked it, I'm putting it forward. I am like a medieval knight hanging my shield on the tree, and any challenger can come by and they can prove me wrong. You have to be willing to say that, or it's not science.
Well, yeah, I know exactly what you're saying, but I've failed too many times on that front, on that battlefield of research. I've spent at least 1,000 hours in this lab doing trying to find that butter zone. It's the hardest thing to do. I would rather, guide the research itself. Like, I know all the things that can go wrong in using microwaves in a tube. I know where all the arcing is going to happen. I know what's going to blow up first. I know the very sound that you should listen for before everything explodes in a bad way. So it's not an easy question to answer.
But it's a question that you have to answer.
I will. I'll tell you what. If I can,
I'm very troubled by your saying, well, if I don't get the desired results, I must have done the theory wrong.
No, not the theory, but the actual manufacture of
No, you don't get to say that. At some point, you have to say, I stand by this analysis. If the experimental results don't agree with it, I'm wrong.
I'll have to think about that, and I'll.
It's a critical divide. It's a critical.
I believe that. I believe that, but it's part of the whole idea of right and wrong. I've already got pegged in one of the chapters of the book I'm writing, and it's hard for me to answer that question in the context of what I'm writing. I will answer that question, but I can't answer it now because that idea of consciousness accepting that everything it has done is wrong is quite a thing. It's quite a thing, and it does have an impact. To say that one's entire past is just fundamentally flawed, and all the work that they've done, I don't think it should be such a thing. I think every scientist with a new idea, has been able to offer at least 5% or 10% of a good idea. Doesn't mean if one part is wrong, it makes everything else wrong. I'm not an advocate of that. I think that's a very dangerous way of thinking, because it also says that if one thing is right, then it must be absolutely right. If I was right, if I was proven right, and I said, yeah, this is right, that would be the scariest thing that would ever happen to me. I would have so many groupies following me. I would be a monkey in a cage with everyone following and listening and baiting my every
One
word.
of the reasons that I'm in this conference is because I like to keep an open mind, although the expression is an open mind, but not so open that your brains fall out. And I want to harvest ideas from the other participants in this debate and see what I can learn from it, how I can my own understanding. But at some point, you have to say, this is my conclusion, and accept the possibility that you were simply wrong and that your last 5 or 10 years of effort was in a direction that may not be unhelpful to other people, but has not conformed to nature. You have to accept the reality that your last 5 years or whatever you put into this is going down a direction that does not conform to nature.
No, I understand what you're saying, but I can't answer that question.
And I think it's very valuable for someone who's annoying like myself to insist that you hang your shield on the tree and be prepared for any challenger to say, no, I'm a better jouster than you, I have better numbers.
Yeah. No, good call.
Okay.
Okay, thank you very much. Stephen, are you done, or do you want to add something?
Oh no, I think that's great. I think I'm done. They're great questions.
All right. Thank you very much for a very interesting lecture, and thank you very much for comments. And